Alright guys, here's the last one. We'll go over it really quick. Okay, so for this one here, I'm not given a KSP, so I can't do the shortcut of knowing which KSP to look for and what my Q is going to be. So what I do is I write out an entire double displacement reaction. Okay, I do that and I look here and I see which one of these two products forms a precipitate. So then I come over to my solubility of common ions and I can see that lead iodine does have low solubility. So that's my precipitate. So then I write out a net ionic equation without the spectators because I don't care about those. And I solve for my net ionic equation here. Okay? So, just like before, I do the dilutions for both compounds. So I got to do dilution of lead and a dilution of iodine in their states here. So, I set up for lead first, my concentration of lead. I set up my dilution formula. So it's going to be 4.5 times 10 to the negative 3 times 25 milliliters, but I convert that to liters. Okay, equals, so the volume of the new solution is going to be 35 over here plus 25 over there. 35 plus 25 is 60 milliliters, so that's 0.6 milliliters. And I don't know the molarity, that's what I'm solving for. So I'm going to multiply these two numbers together, divide by 0.06, and that'll give me my molarity, my concentration of lead. Okay, so there's my first one. I'm then going to go ahead and do the same thing for iodine. I just set it up, take my concentration of iodine from here, 2.8 times 10 to the negative 3. I'm going to multiply that by the volume, 0.35, and divide that by the total volume, 0.06. And that's going to give me 1.63 times 10 to the negative 2. Now, if you look back up here at the equation for lead and iodine, you notice I have this 2 here, okay, this 2 coefficient. So what I have to do with that is I have to come back down here, take my concentration of iodine, and times it by 2. Okay, so whatever the coefficient is in my net ionic equation, that's what I have to multiply my concentration by. Okay, so just remember that. Coefficient times found concentration. So 1.63 times 10 to the negative 2 times 2 is 3.26 times 10 to the negative 3. Alright, so there's my concentration for iodine. And here's my concentration for lead, which I found before. I then take them and I'm going to plug them into my Q equation. Okay, so my Q equation, just so we're all aware, I'll write it here. Q is going to be concentration of lead times concentration of iodine but I gotta square it because of the 2 here. That 2 becomes the power out front. So I plug that all in, square it. If you work it out, you're gonna get 2 times 10 to the negative 8. 2 times 10 to the negative 8. Now, I don't have a KSP on here to compare that to. I don't have lead iodine. So what I have to do is I have to take out my solubility product constant chart and look up lead to iodine. Lead to iodine is right here. It's 8.5 times 10 to the negative 9. When I compare those, 2 to the 10 to the negative 8 is greater than. So I'm going to get a precipitate. So therefore, will form a precipitate. Okay, and that's how you do this one. Hopefully I didn't rush through this one too fast. If you have any questions, just come talk to me. But this is it. That's the end of the lessons.